Let's take a look at two examples on finding the center of mass of a lamina. As usual, pause this video and try to answer the problems on your own. Before working on the solution, sketch the regions using graphing software and visually estimate the location of the centroid. So tansyahin nyo muna kung saan sa tingin nyo pupunta yung centroid. For clarification, no, the centroid is the same as the center of mass for objects pag uniform yung yung density. Okay? So let's go. For our first figure, we want to find the centroid of the region bounded by y equals x squared and x equals y squared. Sketching the graph, we can see that the upper boundary of the region comes from the curve of the equation na x equals y squared. So pwede nating i-disregard yung lower half ng parabola na to. Kaya pwede natin siyang isulat na upper function f, so f of x equals square root of x, and yung lower function g of x natin ay equal dun sa isa, sa x squared. Hanapin muna natin yung mass, which is density times the area. Or in this case, it's density times the definite integral of the region from 0 to 1. You can verify the anti-differentiation steps na ginawa ko dito, pero ang makukuha natin dapat ay mass is equal to the density rho times 1/3. Sunod, hanapin natin yung moment of mass of the lamina with respect to the x-axis. So capital M sub x is equal to rho times the definite integral from 0 to 1 of the quantity square root of x minus x squared times 1/2 of the sum of the square root of x and x squared. Ito yung average nung f and g. Ilabas natin si 1/2, tapos i-multiply yung sum and difference of the square root of x at x squared. Again, verify na tama itong ginagawa nating integration steps. Ang dapat na makukuha natin ay rho times 3/20. Kung titignan natin yung region, makikita natin na symmetric siya with respect sa line na y equals x. So intuitively, masasabi natin na ang x at y coordinates ng centroid ay dapat along this line, or ibig sabihin equal yung values nila. Pero i-verify na din natin. So capital M sub y ay equal sa rho times the integral of x times the quantity square root of x minus x squared. Distribute natin si x dun sa terms, apply the power rule, and evaluate from 0 to 1. Ang moment of mass with respect to y na nakuha natin ay rho times 3/20 din, as expected. Ang location ng centroid ay given ng capital M sub y over m, capital M sub x over m. Notice na magka-cancel out lang yung densities, which makes sense kasi hindi naman dapat magbago yung centroid kahit mabigat or magaan yung object. And we get our location to be 9/20, 9/20. So i-box natin to as our final answer. Sa next problem, hinahanap natin yung centroid ng isang semi-circular disk. Sa example natin, yung radius niya ay 3. Since symmetric siya with respect sa y-axis, we could say na ang moment of mass with respect sa y-axis ay 0. You can imagine na pwede natin siyang ipatong sa y-axis at magiging perfectly balanced na siya. Ibig sabihin din, nandito yung x-coordinate ng centroid sa y-axis, meaning 0 yung x-coordinate ng centroid. So, hindi na natin i-compute yun. Hanapin na lang natin yung moment of mass with respect sa x-axis. This is given by rho times the definite integral from -3 to +3 of the upper function, which is the square root of 9 minus x squared, minus the lower function, pero the lower function is just y equals 0. Then times the average of the upper and lower function, or it's just the square root of 9 minus x squared all over 2. Ilabas natin yung 1/2. Then we'll have the definite integral from -3 to 3 of 9 minus x squared. Wala na yung square root. And we should get our capital M sub x to be 18 times the density rho. So the y-coordinate of the centroid is m sub x over the total mass m na hindi pa pala natin na co-compute. So the total mass m is equal to the density times the area of the region. So instead of doing integration, gumamit na lang tayo ng geometry para isolve yung area nitong semi-circular region. So the mass is equal to rho times pi r squared over 2, kalahati ng area ng circle, or rho times 9 over 2 pi. The y-coordinate of the centroid is 18 times rho over 9 over 2 pi times rho, or 4 over pi pag sinimplify natin. Our final answer is that the location of the centroid is at 0, 4 over pi. And we should box this as our final answer as well. So dalawa lang to na examples. Please take the time to work on more exercises on your own. Pero for now, salamat sa pakikinig.